Good morning, everyone. I welcome you all to the fifth semester in this academic year 2020 to 21. I am here to handle the subject Control System Analysis and Design for you all in this semester. The prerequisite for this course, Control System Analysis and Design, is Signals and System and Basic Mathematics. So what do you mean by control system? Our subject name is Control System Analysis and Design. So first of all, you have to know what do you mean by control system. This class, you will just see an introduction about control system. Before seeing about control system, you will see what do you mean by system. You might have learned about system in your lower semester subject signals and system. So what do you mean by a system? A system is a physical set of components that takes a signal as input and produces another signal as output. So this is what you might have learned about system in a signals and system subject. So what are the examples of system? If you say, means there are so many electrical, electronic, mechanical system running around us in our day-to-day environment. If you see like that, means computer system, fan, refrigerator, AC, car, lift or elevator, and there are so many such systems which are running around us. I hope now you might have recalled about system which you have learnt in your subject signals and system. Okay. Then next we'll see about control system. So what do you mean by a control system? So control system is also a system which consists of number of components connected together to perform a specific function in which the output quantity is controlled by the input quantity. So here in control system, we are going to control the output quantity using the input quantity. Okay. So if you see the example for a control system, means we can take an air conditioner. So what is the purpose of an air conditioner? It is used to maintain the room temperature. How we are going to maintain the room temperature? We see, means we'll be having a remote. So using the remote, you can increase the room temperature or decrease the room temperature as per our need. Thus, we are changing the input to vary the output quantity. So here, in this case, what is the output quantity? The room temperature is the output quantity. If you want to maintain the room temperature at a particular level, you may be increasing or decreasing the room temperature using the input given through the remote. Okay. So this air conditioner is an example of control system. Next, another one example we might see. There is an elevator or lift. If you see, means it is used for taking a person from a floor to another floor in a multi-story building. So for example, I am considering I am in first floor. I need to go to 9th floor. So what I will do? I will enter the elevator and I will press the 9th floor button in the elevator. So here I am giving the input as 9th floor button. Okay, using the 9th floor button. Thus I am giving the input. If I need to go to the 8th floor, means I may press button 8. Okay, thus I am varying the output. Here in this case, what is the output? The person moving to the desired floor in the building. It may be a 9th floor or it may be a 8th floor or some other floor. For that, what we are going to do? We are going to vary the input. Varying the input here in the sense means we are going to change the button to be pressed in the elevator. Okay. So I hope you might understand what do you mean by a control system. So system means is a collection of components for performing a task. Control system means in additional we are adding the controlling mechanism, that is the output quantity can be controlled by the input quantity. Okay, so normally in our day-to-day example, if we see an example of missile, okay, I'm considering a missile. In a missile, we may have a attitude control system. So why we are using this attitude control system means, so we will be launching a missile to attack the enemy country, that it may be a target. Okay, so I'm considering a missile. In a missile, there is a attitude control system, I said. So to maintain the orientation of the missile, so the missile will move from the source to destination. So for moving to that particular target, that the destination, that orientation should be maintained by the missile. For maintaining that orientation, we'll be having attitude control system in missile and all. And one more control system available in the missile is flight path control system. So this flight path control system is used for guiding the missile to the target. Okay, that is, it's for guiding the path of the missile towards the target. Likewise, in a complex system and in simple system, we are having the applications of control system everywhere. Now we are living in automation environment where control system plays a major role, because in today's automatic world we need any desired output automatically. So the input should be adjusted to get the desired output. Okay, so this control system plays a major role in recent technology. Okay, so in our subject control system analysis and design, we are having 5 COs. For each unit we are having each CO. After completing the subject, we'll be able to attain all these 5 COs. The first CO will be able to explain the modeling of electrical and electronic systems. That is, normally an electrical or electronic system is expressed in terms of mathematical model for designing those systems. Okay, for easy convenience, before designing the electrical and electronic systems, it is represented in mathematical model. And how we are going to represent those electrical and electronic system in mathematical model, we will see. And then what are the techniques used for designing those mathematical model, all will be seeing in this first unit. And in the second CO, you'll be able to classify the time response analysis. Here you'll be seeing the system as first order system, second order system, and its time response analysis. There is a system response with respect to the time will be seen in second CO. Then in the third CO, you will be investigating the control system using frequency domain plot. So frequency domain plot means by using Bode plot, polar plot, Nyquist plot, like that. Then by fourth CO, you will be able to determine the stability of a control system. While designing any electrical circuit or any system, you need to determine the stability of that system. Likewise, the stability of the control system can be determined in time domain, frequency domain, and spatial domain by some techniques like Rutherford's criterion, root locus technique. Okay, then by fifth CO, we'll be able to use a state variable analysis for both the continuous time and discrete time systems. Okay, so these are the COs in our subject control system analysis and design. Next we will see what is the need for studying this subject control system analysis and design. So this subject is the basic core course which may get you a job in a control domain. Okay, if you see our NEC alumni, it is Mr. Rajkumar, Mr. Rajesh Raman. Both worked in control domain jobs and now they are owning a private company. Mr. Rajkumar is a proprietor of Basil Automation System Private Limited, Chennai. You can go through the LinkedIn of him. And Mr. Rajesh Raman is a co-founder at ProGyan Learning Center as a MD at Transport Engineering Solution, Kanjipuram. So you can also go through the LinkedIn which I have provided here. So these two alumni or the notable alumni who has worked in control domain jobs and now owning a company that too in control domain. So for getting a job in control domain, the basic subject knowledge you need to have is this control system. Okay, so if you study this subject as a basic knowledge clearly, you will be surely getting a job in control domain. Not only getting a private jobs or becoming an entrepreneur, you can also get a public sector job. Most of the public sector jobs require GATE score. That is, you want a GATE eligible score for entering into a public sector jobs like BSNL or getting into railway jobs or clearing IES exam and all. IES exam syllabus will be similar to the GATE syllabus. So for clearing GATE exam and other competitive exams, control system questions will be asked in an appropriate proportion. If you see the GATE exam means about 12 to 15% questions will be from control system. You can take the previous year question paper and you can see how much questions are asked from control system. Nearly 12 to 15% of the questions are asked from control system. So while studying this subject, you can get trained in the GATE coaching also. While teaching this course, in between I will share some GATE questions to you, so you might get trained for the GATE exam also. So the syllabus given for a control system in GATE is all the things are covered in our curriculum syllabus also in a very detailed manner. So a control system subject is important for entering into a public sector job as well as for getting a job in control domain also. So I hope now you understand the importance of studying a control system. Next we'll go to our syllabus. The first unit is control system modeling. So in the first unit, we'll be seeing the basic terminologies and structures of the control system and the types of control system. There's open loop system, closed loop system, and the differential equations which is used for representing a system, and the transfer function which is nothing but to determine the response of the system with respect to the output and the input of the system. Then we'll be learning about the mathematical modeling of electrical systems and electronic systems. So in electronic systems, we'll be concentrating on op-amp based electronic systems. That is, if you're having a system means to design a system, we need to derive the corresponding mathematical model of a system. So after determining those mathematical model, we may design the particular electrical or electronic systems. So for obtaining the mathematical model from a system, we may use a block diagram reduction technique or signal flow graph technique and all. So all those things will be discussed in the unit 1. So by studying this unit 1, you will be able to gain knowledge in the modeling of electrical and electronic systems. So here The content delivery will be a presentation with lecture with discussion, and will be also having a tutorial problem. It may be a group discussion also. The next unit is time response analysis. So here we'll be seeing about first order system, second order system, and the response analysis. There is impulse response, step response analysis of a second order system and all. That too in a time domain specification. And we'll also be learning about the steady state errors and error constants in our system in the second unit. So totally you will be able to attain the knowledge to classify the time response analysis of a control system from this unit 2. Next unit is frequency response analysis. So here you will be seeing how to obtain the frequency response analysis of a control system by using Bode plot, polar plot, Nyquist plot, and also we will be able to specify the frequency domain specifications from those plot, and we'll be learning about lead lag compensator design and all, and these problems will be discussed in this unit 3. And after learning this unit we will be able to investigate the control system using frequency domain plots. Next unit 4 is stability analysis. As I said earlier, for any system we have to analyze the stability of a particular system. So here the stability of the control system is analyzed in terms of time domain, frequency domain, and spatial domain representation. So for this we are having some techniques like Rutherford's criterions, root locus technique, and construction of those root locus and all will be seeing by means of some problems and some stability analysis technique. Then the Nyquist stability criterion and the relative stability and its associated problems. All those will be discussed in this unit 4. Next, the last unit, unit 5 is state variable analysis. This unit 5 will be seeing about the state space representation of both the continuous time system and discrete time system. I hope you might have studied these continuous time systems and discrete time systems and all in signals and systems. Just we will recall it, and we will be learning the state space representation of those types of system and how to obtain the state equations from those systems and the solutions of those state equations, and some concepts like controllability and observability of a control system. All those will be dealt in this unit 5. Next, if you see the assessment procedure for our subject control system analysis and design, internal assessment test is given maximum weightage, that is 60% of CO mark is given for internal assessment test. For 2.5 units we are having IIT 1, and remaining 2.5 units will be having IIT 2. Then for each and every unit will be having other assessment tools, both in cognitive domain and affective domain. So for first CO we are having the other assessment as Viva, assignment, question survey. For second CO the other assessment is class test, assignment, question survey. For third CO the other assessment is MCQ, assignment, question survey. For fourth CO the other assessment is open book test, assignment, and question survey. For fifth CO the other assessment is Viva, assignment, and question survey. So each and every CO contribute 20% in internal mark calculation. That is, equal weightage is given for all the 5 COs in internal mark calculation. Okay, so give importance to all the COs. Next, The assessment will be evaluated based upon the rubrics. For open book test, we are having the rubrics that is mainly focused on the content what we are giving. That is a focus means the topic which we have asked should be clear enough. Then the supporting information also should be given in a clear manner. The elaboration should be done. This elaboration of the technique should be given in a proper manner. Then organization, that is, we may have given some key points, and those key points should be organized in a well manner. So these rubrics we have taken for evaluating the open book test assessment. Then for our subject, control system analysis and design, these are the textbook and reference book. So generally follow the textbook Control System Engineering by Nagarath M. Gopal. Okay. So follow this book and also follow Control System Principles and Design by M. Gopal, and this book Control System Engineering by Norman S. Nice contains a maximum information in our syllabus. So follow these textbook. I have given all these textbooks in Moodle Classroom, so you can refer it. Along with that, the following reference book is also given. So I have created a Moodle Classroom for our subject Control System Analysis and Design, and I have already invited you all. So go through the syllabus posted in it, and the course plan posted, and the ebooks posted in it, and I will be posting all the PPTs and the recorded videos in the Moodle Classroom for your reference. So go through all those things and study well. Okay. So for successful conduction of our course, particularly during this lockdown period, your cooperation is very much expected. So I think you all will cooperate with me for completing this course successful, both in online as well as in a real-time class. So we'll be having a blended class environment. Okay. In today's class, what all we have seen means we have seen about some introduction about control system. That is, what do you mean by a system and what is a control system, with some examples we have seen, and then we have seen what is the need for studying the control system. That is for getting a job in control domain or for clearing the GATE exams, because 12 to 15% of the questions are asked in control system. Then normally in GATE syllabus, aptitude is also given. So if you concentrate on aptitude and this control system and few more topics, it may be another 2 topic. If you cover means you can get 50% of GATE score, and thus will be a GATE eligible candidate. Okay. So study this subject clearly with a basic knowledge. If you have any doubt, you can contact me. Okay. Thank you.